Thank you, Osama. And we look forward to working together on these related issues. I would like now to pass the mic to the moderator for our first session on digital transformation, realities and expectations. The moderator will be our colleague here, 𝐃𝐢𝐠𝐢𝐭𝐚𝐥, who's the acting director for the Market and Industrial Development Program. Majid, the mic is yours.
Thank you, Dr. Fahd Turki. Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, good afternoon, and good evening, everyone. Before I introduce the speakers, let me share with you a quick background on this topic, and I'm quite confident that our esteemed presenters will touch base on some of these points. Digital transformation is not new to the oil and gas industry. The earliest digital applications are dated to the early 1980s, most of which were in the fields of geosciences and reservoir simulation, which witnessed major breakthroughs driven by the advanced computing. Since then, numerous applications and projects have grown steadily. Most of the progress in the digital transformation space were in pilot tests or in small to medium-sized field and industrial projects. The success of these projects intrigued large operators, both national and private companies, to scale them up. However, many, if not most, and here I'm being the devil's advocate, most of these large-scale digital projects have experienced setbacks and challenges and have under-delivered on what they had envisaged to fulfill. Some blame it on oil prices. The oil and gas industry have experienced drastic oil price swings over the past 2 decades. Oil prices collapsed during the financial crisis in 2008, another incident in 2013, and lately during the pandemic, and God knows what will happen during this new variant. These swings had implications for investments pertaining to digital transformation projects. When the oil prices were high, big companies laid long-term plans to develop and deploy digital transformational strategies and business models. But after the oil prices collapsed, these projects were either postponed or basically canceled. As the oil and gas now is gradually and steadily recovering from the aftermath of the demand destruction in 2020, digital transformation has gained momentum. But the narrative this time is quite different. It's not only about energy efficiency improvement or cost optimization. It's now geared more to focus on decarbonization and combat climate change. Given this brief historical context that I just walked you through, I could not help but to wonder what will happen to these projects when oil prices fall once again. And as we speak, Brent crude is now selling around $70 per barrel. Perhaps the issue is deeper than oil prices. I could be wrong, but let's see what our speakers have to say with this regard. Our first presenter is Dr. Saeed Mbarak. Mr. Mbarak is a worldwide recognized digital transformation expert with over 30 years of experience in various roles and responsibilities in the oil and gas industry. Saeed is currently an intelligent fields and petroleum engineering consultant at Saudi Aramco and the chairman of the Society of Petroleum Engineers Digital Energy Technical Section. He's published several papers and a book to promote innovation and challenge conventional wisdom within and beyond the digital energy and intelligent fields. On a personal note, Saeed Mbarak is a colleague of mine from the old days. I had used some of the innovative applications and tools that he co-developed in the domains of intelligent well completions, which yielded major cost savings for the company at that time. I couldn't find anyone better than Saeed Mbarak to speak about this critical topic and share with his insights with us. Saeed, the floor is yours.
Thank you very much for the great introduction, and I hope I deserve it. Well, I'll be speaking about digital transformation and energy transition and what's in common. I hope you heard the sound is okay and you see the first slide. Let's just say yes, Majid, and
We hear you loud and clear.
thank you very much. And whenever we speak about transitions, we speak about people, maybe technologies or tools and processes. And you will hear these basically enablers or qualifiers for any transition. And let's give you some, historical events and evolution on the societies, and everything, in fact, goes into evolutions, including us. So human being or the society started from hunting to agriculture to the industrial, and now we speak about the digital, and that's really knowledge and super intelligence. And you will hear a lot about the digital transformation. What comes with digital is basically, yes, data. It might be raw data, but it could be even, knowledge and wisdom. In the old days, knowledge-based economy was more of constrained by borders. So if you have an experience or a trial test and sort of a way of hunting animals or farming, then it might be just localized in a certain location. But with the advancements of technology, now we could share and exchange and transfer knowledge in an easy way. And this platform now and the workshop here is just an evidence of how much data will flow between all of us. It's in fact in knowledge and wisdom. So what used to be individual results and innovation, now it's more of collective innovation. And I see Tony's nodding his head and definitely agrees with me. And we've been exchanging enormous of ideas just through these digital technologies and means. Now, when it comes to evolutions, it's not only societies that evolve, it's technologies, and definitely there are very primitive technologies, but now you might be seeing technologies that are built of those simple technologies. Some of them call them advanced, some of them call them complex, and for the devil advocate, definitely they would go to a description of complex technologies. I'm talking to Majid here. Now, industries have also evolved, and you would be hearing about the first industrial revolution, and then the second, the third, and the fourth. And if you look at the fourth in particular, which I have some sort of my own opinion about it, it's just a collective, it's using the technology that exists. Is it really a revolution? I might have a different opinion because it hasn't really changed the way we do things. It's just an integration of existing, technologies. Now, when technologies and industries evolve, definitely regulations and policies do change as well, and even us. And let me just, remove part of this technology because it's blocking the way. Now, before I start the presentation, the real slides about digital transformation, let me just share with you a few tips that are very applicable to both digital transformation and energy transition. Definitely same ingredients don't yield similar results. So you could see company A, be it a national oil company, independent operator, or international operator, speak about the same technologies and their applications with all of the enablers that are associated with the deployment of these technologies. They might be talking about different results. And that's because of the many variables associated with it beyond the ingredients. Now, there is no one size fits all. So different fields, different countries, different policies, different geography requires different applications and different technologies. And whenever one or a company wants to deploy a certain technology, they don't really seek technology for the sake of it, and they seek the value out of it, and they seek the application. So usually it's a fit for purpose. It's not really an entertainment, or an investment that they want to lose. And They would know their capabilities, be it for the people themselves, the technology itself, and the assets that they're operating, and the limitations that are associated with the uncertainties within the technology itself. And definitely, they would have a short and a long term whenever they apply certain technologies. Now, what are the enablers for either digital transformation and energy transition? Definitely technologies. And if you look at the spheres to the right side, the sphere size represents the investment size. So the bigger the sphere, the bigger the investment. So with technologies, they are expensive. And with time, they get advanced, new versions come, and they become cheaper. A newer version comes. So what comes with the advancements of technology is fast obsolescence as well in previous technologies. And that has to be put in the equation. The business environment and how is another enabler, and how companies operate, the organizational structure, how they communicate, leadership, management, and even the teams within the company. And Tony is the expert when it comes to, let's say, business environment and change management, just to bring the environment or the business environment to a level to capitalize on the technologies and other enablers. Then optimization processes. It's just like Uber. What they've used basically is they used existing technologies, but they came up with the business model that uses basically the existing technologies and people. But if you look at these enablers in a different perspective, what you would see here basically is people are the ones basically bringing the highest value. I'm sorry about that. So they're the ones inventing technologies that fits for a purpose. They're the ones know where they should deploy it, and they're the ones creating the environment and coming up with the processes to make sure that these technologies or business environment yield the maximum value for a certain country, a company, or individual. Now, what's with the technology now? And you see some I'm talking about the borderless world. When it comes to the technology, you see the cyberspace, it's just eliminated borders. And now there are people within this workshop from the States, there are people from the Far East, and there are people in the Middle East. So borders are eliminated. Education and knowledge can be transferred easily. There is no border when it comes to it. Climate is the same, and that comes up with the new discussions and the recent discussion about climate and energy transition. Health and the pandemic is an evidence. It seems to be there is no border to even viruses. Economy, definitely, it's a ripple effect. When a country is affected by a certain incidents, then almost the whole world gets affected, especially if the country has a weight. Energy transition is the same. So if you look at the picture over there, children, animals, insects, and fishes see no borders through their innocent eyes, but definitely strategists who see the world as one unit, they should not really think about borders because things affect each other. Now, look at this picture just to demonstrate how basically we look at the world at night. And if you look at it over here, you see where the places that are lightened at night. And that's a reflection of the places that have infrastructure, the places that have power, and they generate power. It doesn't, and they're really advanced. When you look at it, it's let's say the most lucid areas: Japan, North America, Europe, the Middle East, and basically close to the shores. Look at Africa as the darkest place. Now, when it comes to energy and the transition and all the discussions and policies, they don't come up from the darkest places. They come up from the most advanced places, and they're the ones that are emitting the largest amount of CO2. So they're already advanced. They put policies. They're already in a stage where these policies, maybe they can accommodate, but the ones in the dark places, they find it really, really challenging to accommodate these policies if they want to advance, and it would be really expensive. Now, this is a poll that I ran and LinkedIn. Today, would you be willing to pay double what you're paying for energy, regardless? It's gas, it's oil, it's energy, mostly no. And I think people would prefer to pay less. So when it comes to any transition, we need to think of human-centric. It needs to be really affordable, and any change comes at a cost. So who will be paying the bill to do these advancements? And as we stated in the spheres, the highest cost comes to the technology. This is another plot which shows basically the distribution of the world's natural resources. And if you remember the previous one, the world at night, the brightest areas with lots of light is basically the lightest areas here, and they are almost short of resources. Yet the darkest places seems to be the richest countries of resources. That's something to think about. Now, distribution for wealth per adult, and that's money. The brightest places are the ones that are basically with the highest GDP. I mean, they're basically the richest countries in the world. Now, transformation of wealth. I mean, since we're talking about transformation, let's give this example. This is a bar of iron that costs only $5. If you convert it to horseshoes at $12, needles, 3,500. And then balance springs, they're 300,000. And definitely those natural resources that exist in the poor countries, they go to the countries that, make the transformation to the iron bar and to the balance springs that are installed maybe in Rolex watches. And this is why they're expensive. And they're sold back to certain countries, let's say, that need them. So the value really comes if we are able to transform the raw material into more valuable material. It's just like data over here, and people are talking about smart factories, intelligent fields, digital oil fields, and this is the digital transformation. So if you're able to transform the wealth of data, basically, and you will hear about data mining, AI, and artificial intelligence, big data, all of these terms. It's not really a hype. They're using basically the data whenever it's applicable to produce value or insights. It's not only in the government or e-commerce, smart cities, and now e-governments. And if you look at, let's say, Saudi Arabia government, it's one of the most advanced e-governments, and it's just using data, we're creating processes and using technologies that exist, in fact, everywhere. And that's basically it. So if you later on, we'll see you the real enablers when it comes to transition. Now, investment in education and human development. You would see here again, the darker places are the places where the investment on education is the highest. It's again same areas except with additional South America, the Middle East, Saudi Arabia, and Russia, Europe, Japan, and North America. Now, let's see if knowledge shares is knowledge multiplied. That's a quick example to demonstrate the value of knowledge. And if you have an apple, let's Majid has an apple, and I have an orange, and we just exchange. He will have the orange, I'll have the apple. If he has a laptop and I have money, and if we exchange, then I have the laptop and he has the money. But if he has an idea, and it is a great idea, I have the money, I can buy the idea, but he will still, the idea, it still have it, and the money as well. But if I have an idea that's A and he has an idea B, and we just exchange, both of us have both ideas. And this is basically when we say we can collaborate and even transform the ideas into even better ideas. Now, when it comes to the oil, this is how much oil basically the world needs, and this is a 200 years chart, and it shows basically the world needs more energy. So be it oil, alternative energy, the world needs more energy, and that's a call for more efficient energy production and use as well, and exploring the various options to increase basically the sources of energy and where we can get them. Now, there isn't a one size fits all, as we described. So cleaner energy, we have to honor nature, use appropriate technologies, maybe new business models, and definitely collaboration and new policies. But to be fair, everybody has to climb the tree. This is a cartoon I think that you've seen. Not every country can basically, you cannot really apply all the policies into all the countries because they're in different stages of maturity and even GDP and other things, and even education, as we demonstrated in the maps. And now fundamentals are irreplaceable. This is what we go through usually when it comes to an assessment of anything, be it digital transformation or energy transition. We go from collecting data to analysis, decision, and action, and they're really expensive when it comes to the investment. But now with the digital world, if you're disconnected and you rely too much on technology, then you might just end up failing. Now, this is the future. One of the question might, pop up, and the future belongs to, and this cartoon might just demonstrate where a tale of power and I'll stay silent here. And this is a pessimistic person. He has an objective to move to the future. Definitely he has technologies and all the rest of the enablers, but the gap is really huge. So he decides to stay. Pragmatic comes, calculates the thing. And it seems to be very hard to go to the future. And somebody else comes who possesses power and vision. Well, it's a discussion. They formulate a plan and they're able to move to the future. And when they move to the future, it's not only them who move the future. In fact, they create a path for the rest to move to the future, including the pessimistic and pragmatic individuals or mindsets. And they continue march, the rest is fail. Now, what is the most important enabler for any transition or transformation? And this is a poll of many people, it's leadership. And when we discuss the vision of 2030 in certain countries, including our dear country, then that's the thing. You've got power and vision. And this is how you basically could move things a little bit faster, where you could change, even if the vision is solid, but you can change if you're flexible enough. Now, that's a cartoon. It's almost the last slide, but it's when people are close enough to a project or a thing, and considering they're blind and they don't see the elephant, everybody touches a place, they will think that it is the thing. But sometimes a child from outside could see the whole picture. So sometimes we need to zoom out to see the full picture instead of just zooming in and seeing things really close, and we become so blind. And this particular digital transformation and energy transition, the two subjects are, they require a global eye, and because it's a global system. Now, final tips, and that's my final slide. Continuity is really important, and if you look at it over here, it's really a tiny change, but definitely within time, it's cumulative, and it is a big change. And the last thing is plant seeds, grow ideas, and definitely in the future, it's the image. It's something that you can harvest, and if you cannot harvest, then your descendants can. Thank you very much.
Thank you, Saeed, for underscoring the importance of incorporating human-centric approach to energy transition, which sometimes are being misunderstood by many. The human element is key to any successful transitions to any forms of energy we're talking about. Our next speaker is Dr. Mike Roshan, Chief Technology Officer at C3.ai. Dr. Mike has 20 years of experience in various industrial domains related to the corporate, digital, and AI-driven strategic initiatives. At C3, Mike leads the establishment of joint centers of excellence for AI and data analytics, focusing on business deliverables. In his presentation, Mike will talk about the importance of developing back-to-back solutions, especially to embrace the energy transition. Dr. Roshan, the floor is yours.
Yeah, salam alaikum everyone, and warm greetings to Riyadh from Munich. So today we'll talk about digital transformation, about realities, major challenges, and business expectations, specifically in the context of energy transition. First of all, let me mention, and as you know, already several major companies, including Shell and BP, have declared a goal of zero net emissions by 2050. And me, as the person who is in the digital business since more than 20 years, specifically in the artificial intelligence area, I would claim that one of the most important tools for achieving such type of goals is AI. And for instance, for example, AI can significantly reduce emissions associated with the oil extraction and transportation through predictive analytics. At the same time, by constantly monitoring system parameters for various components, AI based on IoT, Internet of Things, can warn technicians days in advance of any problem that needs attention, utilize hydrocarbon fuels more efficiently, and prevent unplanned downtime. AI, with the help of elastic cloud computing, can also enable more efficient use of energy in general and help prevent leaks that drive up producers' carbon footprint. At the convergence of those technologies, of those four pillars, that's a phenomenon known as a digital transformation. And this sweeps every industry. It's at the top of the chief XOs and leadership agenda throughout the world. We at C3.ai, jointly together with Baker Hughes, we deliver enterprise AI software solutions that enable and accelerate digital transformation. Our motto is to provide everything what is related to the technological layer to enable digital transformation. To realize this value, it requires sophisticated technology as well as deep industry expertise. At BHC3, we are tackling some of the most complex business problems in upstream, midstream, and downstream. And today I will give you also some examples on that. We leverage the power of AI, machine learning, Internet of Things, and big data. From well placement to asset reliability, to production optimization, to process optimization. And BHC3 has been solving different business problems for some of the largest oil and gas companies in the world, such as Shell. Our partnership with Baker Hughes will accelerate those innovations and deliver digital transformation for the entire industry. And as you can see, the ambition is really high, and the volumes, the hidden values, are really huge. And there is a place for everyone to cut the piece of cake and to achieve our goals, specifically in the energy transition context. But still, we talk a lot. So like 20 years ago, I still remember when we talked about AI, machine learning, that was really too fancy, right? There was no real business. It was just about the hobby. Nowadays, everyone speaks about AI, but still there are a bunch of roadblocks for digital transformation, despite all possible economical opportunities, right? In terms of reducing non-productive time or production optimization and asset integrity. What type of roadblocks do I mean? And as Said mentioned previously, right? We talk really about people. We talk about their minds. We talk about lack of trust, competences, about innovations. We talk about also the way how the companies deal with people. It's about zero tolerance for any type of mistake. And typically when we try to involve innovations, then we need to fail. We need to fail fast. So we need also to change the corporate cultures on that. Let me talk about the business KPIs. You may probably remember 2008, yeah, the financial crisis, when the standard business models were completely demolished, yeah, completely ruined by the fact that there was no money to buy new equipment. And only few companies were able to provide a completely new business model based on performance-based contracts, which would require a lot of technological competences within those companies. That's just one of the examples. Another small examples related to the KPIs that typically the companies try to address to the vendors, to the technological vendors, yeah, like accuracy of the models, like expectation that 90% of accuracy can solve all possible problems. And this is the wrong KPI, and I will show you on the next slide why. It's also about the process. So no agility, so design specification first. We lose the momentum, right? We spend a lot of time on trying to design things instead of trying to execute those things. We lose a lot of time on procurement that still takes 6-18 months, depending on your business. It's still about the investment approach, yeah, and how you calculate the values. Sometimes it's not about the way that you can directly access the economical value, but you reduce the risk. The same is also about sustainability efforts, yeah. It takes a lot of money, but at the end it pays off because you can really avoid many critical situations. And at the end, it's also about technology. So we know there are a bunch of technology vendors, yeah. There are many already available open source components and systems, but still there is no one unique view on the way how to apply those technologies. And this is exactly the way how we deal from C3.ai and Baker Hughes perspective. As I promised to you, I would like to be a bit provocative today. And first of all, let me reformulate well-known motto that the data is the new oil, and propose to you a bit different statement. Data is a new oil field, either green field or brown field. And if you take this approach seriously from me, then you would understand that why I compare it like this, yeah? So for oil field, you need geologists. And this is in our case of the data, we talk about subject matter experts. You can't really deal with data if you don't have experts from the field who know this piece of equipment, who know this asset, who know this type of process or operations. Let's go further. When we talk about drilling services, it's all about data engineers and how they work on the data. When we talk about, let's say, pumps or different type of equipment, we are talking about data engineering tools. When we talk about production experts, it's about our data scientists. When we talk about well or reservoir models, it's about statistical and mathematical tools. If we talk about water flooding, or we try to find a balance between injection and production wells, it's definitely about data quality approach. And last but not least, infrastructure, it's kind of our BI tools, optimization, planning, solvers, all different type of tasks. It's about machine learning and AI tools. And last but not least, financial economical model for your assets is the same financial economical model, because still we need to understand whether it's worth to invest in our data-driven approach or not. So at C3.ai and Baker Hughes, as I already mentioned, first we try to address technological challenges on your side. And the very first one is really related to the time you spend with your AI or data-driven projects and how you spend this time. And we claim to say that we can be much faster to integrate your data into one unique visual data image that will allow you to build on top any type of data analytics. Second, we are talking about the execution of the projects, right? As I read recently, actually, in one of the articles, that sometimes it takes up to 10 years to execute the project related to digital transformation, starting with an idea and ending up with a modification of the business process. We try at least to come up with a productive operational experience already within 6 months. And that's exactly our objective when we work with the companies. We talk about very complex technological stacks, and that's exactly what we provide on our top from our side as a not only experience, but as a proven and already integrated solution. And last but not least, we are also talking about cross-functional collaboration. So we work with, sorry, there was a question?
1 minute to go, please.
All right.
Not your slides, thank you.
Yeah, and already today, as already mentioned, yeah, we're talking about proven solution, yeah, with billions of predictions, with millions of different type of models, and already hundreds of different customers across the world. So what is so difficult about the solution? It's very easy, yeah? You have a bunch of aspects that you need to interconnect between each other. And that's exactly what we offer from our side as a platform solution that will allow you to cover everything related to your technological demands. On top, what we built is already predefined business solutions that can be easily configured for any type of business demand. And one of them is related to our energy transition that will require real-time visibility across your enterprise. It's about AI insights to minimize energy consumption, utilize cost, and carbon emissions. And this is one of our solutions, which we call BHC3 Sustainability, as a foundation for your AI initiatives for energy transitions. Last but not least, it's worth to mention that we work jointly with Baker Hughes, as I already mentioned, with Shell, with Microsoft, to launch the OpenAI Energy Initiative. And this is kind of an open ecosystem for AI-based solutions for the energy and process industry. And you can always access already existing results and discuss with us the new initiatives and how to deal with them. And as a summary, I just wanted to mention that the main role is about leadership. It's about our CEOs who deal with the companies. It's about the way how they can change the minds of the corporate culture and to come up with a completely new setup to allow this new technological experiences within the company and also digital transformation, yeah, to allow this fast adaptation of the technology in the context of the energy transition. Thank you very much. And if any question, I would be happy to answer. Majid, we don't hear you.
We encourage our presenters to attend to the questions listed in the Q&A box. Thank you, Dr. Mike. Indeed, one of the setbacks experienced before is that many developers are operating in silos. For digital transformation to succeed, it is very important to develop end-to-end solutions and agile business models to nurture innovation and embrace digital transformation, especially in this era. Our next presenter or final presenter is Dr. Tony Edwards. Dr. Edwards is regarded as one of the key thought leaders in digital oil and integrated operations. He was a founding member of BP's Integrated Operations Program and was subsequently the Global Director for the Advanced Collaborative Environment Program that rolled out real-time collaboration centers around the BP portfolio of assets. In 2006, he moved to BG Group to launch its digital oil field program under the name iValue. In January 2009, he co-founded Step Change Global, a dedicated digital oil field consultancy and advisory company, providing consulting services to many leading oil and mining companies, including ExxonMobil, Chevron, and BHP. Dr. Edwards has actively participated and continues to engage at many functions and conferences related to the digital transformation space. Given his expertise in the oil and gas industry, both as a developer and a consultant, we're very delighted to hear his thoughts on the pace and size of digital transformation in the near future. Dr. Edwards, the floor is yours.
Thank you very much. First of all, thank you very much for the invitation to speak at this excellent event. I'm going to skip over the introduction to StepChange Global and concentrate on talking about new digitally enabled operations and organizational models. Just a little bit to say that we've been fortunate enough to work with a lot of great companies over the last 10, 12 years, and this is an aggregation of our experience in oil and gas, mining, and indeed the chemical industries. So what I'm going to talk about is the new digitally enabled operating models, which are enabled by these suites of technologies. So you've got all these technologies, IoT, analytics, machine learning, mobile worker, automation, robotics, drones. Really, what does it all add up to? What does it add up to, and what does it mean to operations guys? And I used to be an operations guy working offshore in the North Sea. What does it mean to people in the field who are actually running operations, who are running production systems, who are maintaining production systems? And the change in the way of working really adds up to these kind of things. It's about moving to a real-time way of working. It's about removal of the geographical constraints. It's about moving to a more multidisciplinary way of working. It's about value chain integration and optimization. It's about being more proactive and predictive. And really, this is summed up by new digitally enabled remote operations models. And so, you know, these remote operations models and the data and information that we get are able to transform marginal brownfield operations, marginal greenfield projects. They're able to maximize production optimization. We're able to significantly drop OPEX. We're able to maintain and improve HSE performance. We're able to reduce CapEx in greenfield operations. And it's a combination of these digital technologies which is applied to an operation that is truly transformative. So what are the type of operating models that we can look at? And, you know, we have an equation as well. We have this equation which we say NT plus OO equals EOO. And for us, that means new technology plus old organization equals expensive old organization. So the challenge, we believe, is how do you align your organization and operating model to make use of all this data and information and do the fundamental things that we do in the oil and gas industry, which is produce oil and gas, you know, drill, develop new prospects, et cetera, So the operating models that we're seeing and that have evolved over the last 10 or 15 years, first one is remote operations and engineering support. So you have the data and information, it comes off of your operation, it comes off a pump, a compressor, or well, whatever it is, it comes into an office environment and it is analyzed by a set of engineers who look at opportunities to improve that, improve the performance. That's the first model, and that one has been around for 15 years now, even more, and is actually quite common globally, and many companies have implemented this kind of model both at the asset level and at the center of excellence type level. The second model we see evolving is the addition of remote control. So can we actually remotely control these operations from city center locations or other locations other than the actual operational site? And that's driven partly by the remoteness of the operational sites, but it's also being driven by the need to have the best people and where locate your control systems where the best people are. And the third model, which is really evolving, is the idea of having radically unmanned or minimum manned operational concepts. And this is coming through primarily in greenfield developments, but we're also seeing it being applied to brownfield developments to significantly drop the manning of an offshore platform in the North Sea or offshore Angola by something like 50%. And we see that the digital technologies play a huge part in that. And what I would say is that these models are key to actually getting the payback from spending all this money on the data and information and accessing that data and information. So here's some examples of remote operation support. And again, you can see that typically there is a center, there's a co-located set of engineers, and this is where the data and information comes into, this is where the new processes are evolved, and this is where the decisions are made. And so these examples you see here are global examples from ConocoPhillips in Calgary, from Santos in Australia, from Chevron in Perth in Australia, for a variety of different operations, whether they're offshore operations, onshore operations, drilling operations. This model is pretty well established now, and you will find many of these types of environments in many different companies. Of course, many of these environments are never, there is an issue around, you have to set them up properly, you have to look at the people issues, you have to look at the organizational issues. Frankly, the technology and the process change is the easy bit, but getting people aligned to work in this way is really the challenge, and that's what we focus on. The second model is combining the remote engineering and operation support with full remote control. And this is something which is evolving fast. It is something that's been going on for about the last 10 years. So if you see the example in the top left-hand corner, we worked with Santos 10 years ago to develop a combined remote control room for their GLNG, coal bed methane to LNG project. So they now are remotely controlling 5,000 wells and all of the associated equipment from a single facility in the center of Brisbane. Other examples on here, one is a midstream pipeline company which consolidated 27 control rooms in the field into a single control facility based in Houston. The one in the bottom of the page in the middle is a mining example, which is and the miners have been very much leading on this new remote control operating model. And the one at the top is actually a platform in the Norwegian sector of the North Sea, which is being remotely controlled from the beach. And what we're seeing is that this idea of remote ops and remote control is very much an emerging trend for new greenfield projects, but also there are a number of companies looking to apply this to their brownfield portfolio. Just a shout out to the miners. The mining guys have been looking at full remote control for more than 10 years now. And here's some examples of highly complex operations in the field which are being remotely controlled. So we've got examples, the top left example is actually a remote control and integrated operations center in Santiago, Chile. And that's remotely controlling the largest and most complex mine in the world called Escondida. There's 16,000 people at that site. And this facility is, an hour and a half flight away from that in the center of Santiago. And, we see companies like BHP, like Teck Resources, like Rio Tinto and others doing this. And they're doing some fantastic work at combining remote control, which would have been distributed in the field into a single location.
Can you hear me, Dr. Edwards?
Yes.
Yeah. Please wrap your presentation. We have a minute or two to go.
Sorry?
Please wrap your presentation. We have 2 minutes to go.
Okay, yeah, this is the last but one slide. So the final evolution of the model is looking at radically minimum staffed or minimum manned facilities, and how do we build that into the design. So what the question we're trying to answer is, if you take a brand new operation, a brand new project and developed it from scratch, and you threw all of the digital technologies at it, what does it mean for the operating model? And what we see is that you end up with operations which are remotely controlled, unmanned or minimum manned. And the current state of the art is that basically all gas operations can be remotely controlled and unmanned. The majority of oil operations can be remotely controlled and minimum manned with a standard crew of less than 20 people. And we see that that has the ability to significantly drop the predicted OPEX and the predicted CAPEX. OPEX around 50% and CAPEX around 10 to 50%. So the summary is that, what do these digital technologies enable you to do different in your operating models? And really, that's where you make the money. That it's about lowering OPEX, it's about lowering CAPEX, it's about increasing production and doing those with the suite of technologies. And we don't believe that any one single technology will deliver the whole transformation. It's a combination of those technologies and how you apply that to your operating model. And not only that, we can do this now. Many of those examples that I give are over 10 years old now. So actually, you can do a lot with readily available technologies, the base technologies of having data and information and being able to do analysis with that and being able to enable these remote operations remote operating models. So thank you very much. That's all I've got. Thank you.
Thank you, Dr. Edwards, for defining the digital transformation at the very beginning and explaining how the operating models have evolved with time, attending to different sets of challenges experienced over the past 2 decades, as well as highlighting some of the successful projects across the energy landscape. Unfortunately, we're running out of time, but we can ask you and the rest of the speakers probably one question before moving to the next session. In your opinion, given your expertise in this field, and as the oil and gas industry embraces energy transition, who do you think the winners and losers are in this domain? So probably we can start from Saeed and then Dr. Roshan and last by Dr. Edwards.
Well, I'll try. Anyway, the cartoon says it all, by the way. The winners are those who have power and vision, and in fact, who execute things. So it's not really a propaganda or, they walk the talk. And definitely that requires an investment, and it could be a pre-investment where they basically create the way to others, but definitely they're the first one to harvest. There might be challenges, there might be few mistakes, but definitely, in the oil and gas industry, mistakes in certain places are almost as a no, because they could be catastrophic. So it's really calculated mistakes or calculated basically implementations of things to produce basically the value. So it's power and vision. People who are marching first are the ones to harvest first.
Yeah, let me step in. First of all, personally, I hate to speak about losers, right? I don't want to speak about losers. Yeah, we don't have them. And there is no good pattern to talk about winners, yeah, who can win in this situation or not. But nevertheless, still, those who is able to be aware about the current issues in terms of the business and threats, actually, what's going on there, and also to react and to propose a new agenda. Those have a best chance, let's say, to win in the whole situation, yeah? And just to give you one particular example, yeah? We were talking just recently about associated petroleum gas, right? This is the thing, come on, in oil and gas, well known, right? And either you burn it, yeah? And you lose your sustainability goals, yeah? Or you try to reuse it, very easy, yeah? Why digital, yeah? Because this is the only way, just simply to control that your infrastructure is able to deal with this in the full scope. That's it, right? And that's exactly the way, one of the things, yeah, very practical, that can help you to win your sustainability objectives. Thanks.
Thank you, Dr. Wilson. Dr. Edwards?
Yeah, I think if you take the view that digital transformation is a digitally enabled organizational transformation, it's going to be the companies and entities who are most change friendly. So the companies that have a culture which will allow them to adapt and evolve over time and make those changes. I think one other thing is that when you're doing this, there are a number of things which are become a challenge. So size, scale, diversity of geography, diversity of cultures, and diversity of assets is not helpful. So if you are a regional company or a smaller mid-sized company with a low diversity set of assets, this is definitely easier. There's no doubt about it. So the companies which I think are going to find this difficult are the big IOCs with global footprints, with many different cultures, many different geographies, and many different asset types, because the amount of commonality that they've got to apply the technology is much lower. So if you've got a low diversity set of assets and you're more a regional or a country-based company, it's definitely easier.
Thank you, Dr. Edward. And with that, I conclude the session. James, the mic is yours, and apologies for stealing 5 minutes of